Hello students, I am Dr. Varsha Hutke, Associate Professor, Department of Botany, Government Vidarbha Institute of Science and Humanities, Amravati. Today we will talk on the topic micropropagation. We will see this topic under following heads, that is definition of micropropagation, stages of micropropagation, advantages of micropropagation, and the limitations of micropropagation. So friend, first we see what do you mean by micropropagation. You know about the process of propagation, that is the development or the multiplication of the plant. Here in this process also we will develop or the multiply the plant by using very small tissue, that is the micro tissue. That's this terminology is micropropagation. That is development of large number of plants within a very short period of time by using very small tissue that we call it as explant whenever culture aseptically in artificial medium and develop under controlled condition. That is about the micropropagation. This technology is extensively used in the field of horticulture, floriculture, and it is employed in the large scale production of the plant like banana, tomato, and the apple. It is also used to propagate high yield disease resistant varieties in the very short period of time. That is the about micro propagation. Now, why we will see why there is a need of this micro propagation. Basically, in conventional method of propagation, there are the two methods, that is vegetative propagation of the plant and the propagation by using the seeds, that is the sexual cells take part in the process of propagation. Now, this micropropagation is the example or the process of vegetative propagation of the plant. Now, in conventional method of propagation of the plant, it is having some limitations. Suppose if you want to develop the A plant, there is a limitation, that is to take the number of cuts from this plant. And you can develop the very small number of plants from this single plant. But in case of process of micropropagation, you can develop large number of plants, that is from the single or the small tissue, that is the micro tissue. You can develop the large number of the plant. It is the way of rapid multiplication of the plant. Or in case of the plant which is not having the seed organ, only the vegetative propagation is the method. For example, in case of the banana, in that case also it proves very important, that is the process of micropropagation. That's why this process is most important. And micropropagation is the only technique which become first commercial in the field of plant tissue culture for the human kind. Then we see the stages of micropropagation. It is a very well defined process and it is having its four stages, that is the initiation of the aseptic culture, multiplication, that is shooting, and then rooting to these multiplied shoots, and finally the hardening process of this in vitro developed plant. Now first we see the first stage, that is initiation of the aseptic condition. Now this initiation of the aseptic condition is having the three parts, that is selection of the elite plant material, process of surface sterilization of this elite plant material, and the selection of the media to grow this plant in vitro. Now suppose you have decided to develop the plant by using the technique micropropagation in the laboratory. Then whatever your source material, it is in the environmental condition, you have to bring this material from environmental conditions to the laboratory for the further process. Now whenever you bring this material from the field, there is a large number of plants available in the field. It is better to take the plant from the nursery, which is having the less number of the spores of microorganism, but in all cases it is not possible to take the plant from the nursery, and in that case you have to go to the field and you have to bring the plant. But whenever this plant in an environmental condition in the field, it is having the number of spores of bacteria and the fungi on it. That's why there must be the proper selection. That is the selection of elite material. Suppose you are selecting the plant of banana, see the plant in the field which is having the luxurious growth, which is free from the any fungal or the bacterial or the viral diseases, and bring this plant into the laboratory. That is, take the elite source material. That is the first step, to select the elite plant material from that field. Now you have selected the elite plant material from that field. You have bring this material into the laboratory. Now further process of development of plant in the laboratory start from this. Now there is a plant which is in environmental condition. You bring this plant from environmental condition to the laboratory. Now whenever you bring this plant from the environmental condition, you detach this plant from the mother plant, that we call it as a explant, which is your source material. Along with that, it is having some mud dust particle on its surface, and as well as the spores of bacteria and fungi. Before starting to initiate this culture, you have to go for the process of surface sterilization, that is aseptic preparation of the plant material. Now first wash this material, that is your source material, your explant, with the running tap water. Thoroughly wash, you have to wash thoroughly this material with the running tap water, and then give the treatment of some fungicide like the bavistine. That is, wash this material with the 1% solution of the bavistine. Then again give the treatment of 70% alcohol. After each treatment of this chemical, that is whether it is bavistine or the alcohol or the sodium hypochlorite, mercury chloride, you have to wash the material, that is your source material, with the distilled water after each treatment. That is, the traces of this chemical should be removed from the your source material or your explant. Then after 70% alcohol, wash this material with the 1% sodium hypochlorite. Then again wash with the again wash with the distilled water, and finally wash this material with the 0.1% mercury chloride. It may be the time duration, that is 5 to 10 minutes. It changes according to the delicacy of your explant. On the explant, whether you are taking this from the underground or it is from the aerial portion. According to this, we can change the percentage as well as the duration of the treatment. Now this is your final treatment of the mercury chloride. After mercury chloride, you have to wash the material with the sterilized distilled water, and this process must be completed under the laminar airflow, that is in a aseptic condition. Now after using this entire protocol of surface sterilization, your source material, your explant, is ready to transfer in the media. Your material is ready to transfer, that is, it is ready to inoculate on the media. Then next is the selection of the media. Now there are various kinds of media is available. Mostly there is a utilization of mourache and scooped media, which is having the macro elements, micro elements, vitamins, proteins. For the solidification, we will use the um, that is, we will use the agar, and the most important is the use of phytohormones or the plant growth regulators. That is, the we will use the previously prepared MS medium, which is having the combination of the hormone. That is, the development of the plant under aseptic condition in an artificial medium in a controlled condition. Now after this entire process of the inoculation in a previously prepared medium, you have to shift this material in a physical control condition that we see in the latter. Now, after initiation of the culture, the next most important stage, that is the development of the shoots from this initiated culture. You have detached it from the mother plant, and they must establish in the laboratory first, and then there is a initiation or there is a development of the shoots. First, it should be initial. After initiation, then there is a multiplication or the shooting processes start. Now there are three ways of process multiplication depending upon the type of your explant. That is through callousing, that is either shoot bud regeneration or the somatic embryogenesis. Then advantageous bud formation, that is get the shoot from the formation from any other organ than the node, that is the development of the clone, and the development of the plant from the axillary branching, that is most commonly used in the process of micropropagation. You can use any of this protocol. If you want the variation, that is in case of the floriculture, you can go for the callousing. Or if you want to develop the clones, then you will adopt the advantageous bud or the axillary bud. Now suppose we will take here the example of development of the banana plant or the micropropagation of the banana plant. You bring the suckers, that is from the mother plant, from the field. You have adopted the process of surface sterilization. Then you initialize the culture by that is the meristem culture, and then there is a development of the multiple shoots from this initiated culture. Here, the media is the MS medium. If you want to develop the number of shoots, you have to add the shoot inducing hormone, that is the cytokinin. That is your media combination is MS medium plus the cytokinin. It may be the 6 BAP or the BA. Chondroitin or the zeatin, but mostly there is a utilization of the 6 BAP. You will add the 6 BAP in the medium, and then you will take this initiated culture from the growth room again to the laminar airflow, that is under the aseptic condition. You will cut this apical meristem into two parts, and you will inoculate this tissue again in the previously prepared MS medium, which is having the hormonal concentration, that is the cytokinin. And then you will keep this entire cultures, for example the cultures of banana, for the development of the shoot in the aseptic or the controlled physical condition, that is in a growth room or in the growth chamber, where the physical condition is of the temperature, humidity, light, and the photo. Normally, the temperature we will set for the development of the plant within the laboratory is 25 plus minus 2 degrees Celsius. Photo period is 16 hours light and 8 hours dark. Humidity is 55% and the light intensity is 2000 to 3000 lux. You have to keep this culture for 21 days to 25 days in a growth room, and then after 21 or 25 days there is a multiplication of the shoot takes place. Again you bring this culture in the laminar airflow, cut this, and again inoculate in the next same combination of the medium. That is called as a subculture. That is subculture 1. You can go in case of the banana up to the subculture 7, because after subculture 7 there is a chances of formation of variations because of the constant contact of this explant in the cytokinin. That's why we will prefer the subculture 7 only. After the subculture 7, you will having the huge number of the shoots in the growth room, that is your targeted previously. Like what number of the plant you want to develop, make the plan, and according to this you will initiate the culture, and then you will multiply the number of shoots in the laboratory, that is in the stage of shooting. you will get the ample number of shoots in the growth room, that is your targeted number, that is the entire process of the shooting. Now next is the routing to this in vitro developed shoots. Now after good elongated shoots, the final stage is the routing to this in vitro developed shoot. Now this routing process is in very high energy intensive steps, and it is the last stage. That is, the plant is throwing the next organ, that is root. In this case, we can reduce the sugar as well as the organic salt concentration in the media, because here we want the roots only. Now there is no any kind of shoot multiplication. The multiplied shoot we have previously done in the multiplication process. Here only we want the roots to the in vitro shoots, that we can reduce the sugar as well as the organic salt. So here also we will use the MS medium for the initiation of the root. Only the change is at the level of the hormone. Here we will utilize the hormone which is responsible for the rooting, and the auxins are the hormones which is utilizes for the process of rooting to the in vitro shoots. What we have to do? We have to bring this entire shoots in the laminar airflow. We will separate these single shoots and we will inoculate this single shoot in the test tube which is having the medium, or in the culture tube which is having the medium MS plus the auxin. It may be the indole acetic acid, indole butyric acid, or the naphthalene acetic acid. We have to place this entire in vitro shoots in the media for the process of the rooting. And now again you have to incubate this entire cultures in the growth room for the growth of the next organ, that is the root. Again after some 25 days you will find that there is an initiation of the root, and there is a proper development of the root takes place to each shoots which you have developed in vitro. That is, there is a process of rooting. Now after this process you will have the entire shoot and the root, that is the plantlet in the growth room. Here this is the final process in the laboratory. Now after this proper development of the shoot as well as the root, you have to bring this material again into the land, to the environment. You have to supply this material to the growers. Now this process is the hardening of the plant. Now, as you have developed this entire plantlets, that is shoots and root, in the laboratory, in the artificial condition, in a controlled condition, that's why they shows the low photosynthesis rate as well as non-functional stomatas, and the cuticle wax is low on such a plant. That means they are in a controlled condition, they are in a likewise somewhat pampered plant, so they are very delicate. If you bring such a plant directly to the environmental condition, there is 100% mortality of this plant. So we have to bring this material from the laboratory to the land by step, and that is the process of hardening of the plant or the acclimatization of the plant to the environmental condition. And for this we will utilize the polyhouse or the shade house. Now suppose you want to go for the today you want to go for the process of hardening. What you have to do in the previous day, you have to bring this entire culture from the growth room, that is from the control condition, into the washing area of the laboratory. That is, there is no control condition of the temperature, humidity, light, or the intensity of the light. You have to bring this entire material within the washing area, keep there for the overnight. In the next day, what you have to do, you uproot these shoots, in vitro shoots or the in vitro plantlets, along with the forceps, and wash in the water. That is, whatever the media is added to the roots, it should be removed from the roots, because the contamination chances increases whenever this medium is get attached to this root. That's why you have to wash first. Then after this, what you have to do, you have to transferred this, you have to transfer this entire plantlets into the pot trays, that is in the nursery trays, which is having the medium, that is soil, right, or the coco pit. You cannot directly transfer this plant or the plantlet from the media to the soil. First, you have to shift them in the soil, right, which is somewhat porous than the soil, because the roots, whatever develop within the laboratory, these are very delicate. They cannot directly penetrate the hard soil. That's why we will first they shift in the soil, right, where the porosity is more, or the coco pit. We shift this entire plantlet in the pot trays, which is having the soil, right, or the coco pit, and we will shift these portraits to the polyhouse for the further growth. We will keep these portraits in the polyhouse for 2 months or the 2.5 months. Meanwhile, half months. Meanwhile, we will go for the spraying, weeding, like this process. After the period of 2 or the 2.5 months, the plant becomes little bit sturdy in the soil, right. Now the next, we have to take this plant and shift this plant in the polybags within a soil. That means your plant is now in a soil in a polythene bags. You have to keep these polythene bags in the shade house. That is the it is called as a secondary process of hardening, and in the polyhouse it is the primary process of the hardening. Now you have to shift this entire carry bags within the shade house. That is, again you have to keep this plant 2 months or 2.5 months in such a conditions for the further growth. And again you have to weeding, watering, mean. After the 2.5 months, your plant becomes more sturdy. There is a sturdy shoot system as well as the well-developed root system is developed. Now your plant is totally hardened. It is ready to sell. It is ready to sell to the growers of the plant. This is the entire process of the hardening of the plant, and this is the entire process of micropropagation of the plant. That is, we have bring the material from the land, we process in the laboratory, and again we will ship this processed plant material, whatever our aim is there, into the field. That's why this is called it as a lab to land technology. So friends, this is all about the process of micropropagation. Thank you.